Because I recall giving you question 1, 2, 3, 4, 5, and 6, right, in class to do. But did I manage to go through question 5C and 6A? I managed to go through it? Did I? Go through, Sure. Exercise 12.2, question 5C and 6A. I did, right? Okay. I'll just finish up exercise 12.2, question 7 and 12 first. Then after that, I'll go through. Today got homework due, right? There's homework due today, am I right? Read that half inside. Homework due today, right? 12.1. But how come it's not here? I remember I gave 12.1. Am I right? You all do the homework? Okay. So I finish up 12.2. Then after that, we go through the homework. Okay, let's look at question 7 in your textbook, page 14. Okay, let's see question 7, part I. We want to show that x over x plus 1 is actually equals to 1 minus 1 over x plus 1. Okay, please settle down. Okay, how do you think we can actually go about showing this? Does it remind you of anything for x over x plus 1? Partial fractions, okay? Okay, it is our partial fraction format, alright? So in case you have forgotten how to do partial fraction, we notice that in the numerator and the denominator, the degree of the polynomial, okay, are both 1. So because the degree is the same, okay, in order to do our partial fractions, we have to do our long division first. So we are taking x divided by x plus 1. Okay, so it will be 1 and then x plus 1. So we are left with negative 1. Okay, so it's a very short long division that we're doing. Okay, so x over x plus 1 is equals to 1 over x plus 1 minus 1. Okay, hang on. Right. Sorry. 1 minus 1 over x plus 1. Okay, the remainder on top of the denominator. Okay, so therefore, show it. Yes, show it. Next, we look at part 2, where we want to differentiate x over x plus 1. Okay, so at this juncture, the rules that we have when it comes to differentiation are rather limited. We only know our power rule, okay, our chain rule so far. Right? So how do we then go about differentiating x divided by x plus 1? So in part I, they actually ask you to split out the fraction into 1 minus 1 over x plus 1. So that is actually a hint in order to solve this one. So let's just apply that. So instead of differentiating the fraction over here, we will differentiate its partial fraction form. Okay. So when I want to differentiate 1 minus 1 over x plus 1, I could also see it as differentiating 1 minus x plus 1 to the power negative 1. Okay. So if we're looking at our sum and difference rule, whereby I can split out the differentiation, when I differentiate 1, a constant number itself, I'm going to get 0. And then I will differentiate x plus 1 to the power of negative 1. which is to bring down the power minus 1. Chain rule applies. Okay, so inside the brackets itself, our derivative will be 1. So our answer becomes 1 over x plus 1 squared. Next one, we want to differentiate 1 over 4 minus square root 16 minus x squared, then bracket square, with respect to x. Okay, how would you go about doing it if we were to have this? What will you do first? Yes, Joseph? Expand the bottom. Okay, so what Joseph is saying, we expand the denominator. Any other options that anyone else has? Expand? Yeah. Quotient rule, we haven't learned quotient rule yet, so we cannot use that. Okay, how else do you think you would have done it? Sorry? Put on top, okay, so that means change it to a negative index. Okay, so let's see, alright, we are looking at two options over here. One of which is to expand the denominator, so let me just get it expanded. Okay, so this is one option. The other option is to have it like this. If I were to simplify this, I will be looking at this. Okay, so two methods over here. Alright, now that I have actually simplified it in this manner, how many of you will decide to continue with this first method, which is the blue one? How many of you will continue? Joseph, will you still want to continue with this plan? C first. Yeah. So what is your consideration? You see already, ma? So you see first, you want to see second?
Yeah.
Huh? You want to continue? Okay, then if you want to continue, how would you do it?
So you see, I bring up the entire thing up.
Okay, change it into a negative index form. Then
Remove the square root inside.
How do you remove the square root inside?
Making bracket half.
Oh, okay. Change it into a power of half. Okay. Let me just delete this one. Okay, then times the half in. As in bring the power half in. Can you do that? It is not impossible to continue. It's surely possible. Can you can continue one? You want to rationalize this one? Okay, if you want to rationalize this, then you'll be you cannot rationalize in the first place because rationalization is for when the cert is in the denominator. Okay, it's a fraction that we're saying. So you still want to continue with this? Or you want to abandon plan? Abandon plan? Okay. Alia, what will you choose? To do that? Or this? Okay, so the purple one. How will you continue? So we are looking at having y equals to this. So our dy over dx will be equals to, sorry, -2. Oops. 4 minus. Okay. Power of -3. Bracket. Okay, let me bring this down. Bracket. -12. -2. Bracket -2x, is it? Like that? Okay. Then anything else? Or close bracket? Okay, so Alia got this as a derivative. Let's do a check whether that will be correct. So when Wayne actually proposed to put it as a negative index, okay, what Alia did was to bring down the power. Okay, so that's fine. Then after that, if you bring down the power, after that, this whole thing, we need to have the power -1, so become -3. So these two portions here are done well. Okay, the chain rule is applied. Then after that, to complete the chain rule, we need to differentiate this. Okay, which is this part over here. So we need to check whether this differentiation is it correct or not. Okay, so to actually maybe simplify the way we look at it, right, we could actually see it as this. So in order to differentiate the inside, okay, I need to see that differentiation of 4 becomes 0, so there's nothing for us to consider. Then we need to look at the derivative of here and then. So negative, bring down the half, so that's what's done. Okay. Then we need to have 16 minus x squared to the power of half minus 1. So we are doing chain rule within chain rule. You understand what I'm saying? Okay. So therefore, if I want to bring down -half, this is correct. But what about 16 minus x squared to the power of half minus 1? So that is missing. Okay. So therefore, this derivative here is incomplete. Okay. So let me just write things out plainly. Okay, so let me erase this. Okay, so we were saying just now, bring down the power -2. Power here -3, differentiate the inside, so I'm looking at a 0, minus away half, sorry, not down space actually. Okay, I'll just continue here, 0 minus away half, 16 minus x squared, half minus 1 is -half. Okay, differentiate the inside of the bracket, you will get -2x. So this itself is the derivative of the brackets over here. You all follow? Anybody can't understand? Yeah. So simplify our work. Let me write it in one straight row first. So in this case, we get -2 times -half, we get an x, 16 minus x squared. So this will be our simplified form. Yeah. What? No, I never use any product rule of motion. I'm using our rules that we have so far. I haven't introduced product rule of motion really. Yeah. Okay, so our derivative in the end is a very complicated form. Alright, it is solely using chain rule and power rule only. Okay. Any questions? Right. Or you copy, I'll also differentiate using what Joseph was saying just now. Okay, so how would it have appeared if you actually did the expansion? I think I'll just end it here like that in its simplified form. So if you had chosen to expand the denominator, okay, as per what Joseph was suggesting, you would end up getting it expressed in this manner. Then after that, you will apply chain rule to this form. So I brought this up here. So to apply the chain rule, we bring down the -1, keep the things inside, power become -2 because -1 minus 1, alright, -1 minus 1. Then differentiate the insides of the bracket. Differentiating 32 will give you 0. Differentiating -8 16 minus x squared to the power of half. Okay, let me use the color to indicate. Differentiating this part here will give rise to this, where we use chain rule. So -8 I keep, half bring down. This power here -1, so I get -half. Differentiate inside of the bracket, we get -2x. Minus x squared, differentiate 8, I will get -2x. So this is the differentiation. Okay, then next I try to simplify it. -1 is up here. This is whole thing power -2, so I brought it down to denominator. Over here, 0, I just eliminate it away. This one, 8 times half, I'll get 4, so -4. -2x is in the numerator. negative half denominator, so square root 16 minus x squared, minus 2x, I'll just leave it here. I simplify the numerator here, I got 8x, okay, then I'll just leave it at this as its most simplified manner. There's no point in me trying to expand further anymore, otherwise it will only get longer and then it will get very messy. This is also considered simplified, okay. So why is it that I want to show you both methods, okay? Because at your level now, likely there's a chance, okay, or when you are looking at it during the exam, there is a chance that you get yourself nervous and then you end up doing this. Okay, even when you do this, right, there is a way out. Okay, so you need to know how to get yourself out also. Okay, but of course the way out is complicated, okay, and require a lot of careful following of where you're differentiating. Right, it would be neater if you had done it, okay, just by bringing up to power of negative 2 without expanding. Then after that, it would be neater in some sense. Okay, the answers are both equivalent. Alright, they are both equal, they will both be correct. Okay, as long as you differentiate it correctly. Any questions? Okay, if no questions, then 12.2 we're done. Okay, so homework for 12.2. Alright, will be these questions. Okay, your 12.1 homework was this. Alright, so could you take out your 12.1 homework? Could I erase? Never say just now. Okay, 12.1, question 4B, any problems? 4B, 4D, 5B, 6C, 6E, 6F, 8, 9, don't have, or is it never do? Wait, down there nodding, okay. Anybody else never do? Okay, anybody else? Then the rest of you who need no problems, is it? Okay, that would be great. Alright, could you submit your homework to the front? Okay, next we will touch on our product rule, which will make a lot of things much easier to handle. Okay, especially things like, as in for quotient rule, it would be easier for us to have solved the previous question. differentiation, okay, we know how to actually go about differentiating. If let's say I have maybe x squared plus 3x, okay, or even x squared minus 3x. If I want to go about differentiating these things, what my sum and my difference rule tells me is that I can differentiate in parts like that. Okay, so I can take things individually and then after that I differentiate it. But when it comes to product rule, okay, that will not apply. Our intuition, okay, will not be the same, okay. Meaning to say that if I want to, let's say, differentiate maybe x plus 1 squared and then 3x minus 7 to the power of 5. Okay, so I have two terms here multiplying with one another. Alright, it is not going to be equals to taking the differentiation of x plus 1 squared and then after that the differentiation of 3x minus 7 to the power of 5. So that is not going to be true. Okay? So how do we actually go about doing our product? It will be, okay, giving you an example here. To continue with this one, I will first keep the left side. That means x plus 1 squared, I keep the left. Then I differentiate, I multiply, differentiate the right side. So keep left, differentiate right. Followed by I plus, keep the right side, differentiate the left side. Okay, so it is a sum that we're looking at. Keep left, differentiate right, keep right, differentiate left. Okay, so that will be how you will remember it. Can you remember what? Sorry, I can't hear you. Trigo. How of trigo? Okay, so keep left, differentiate right, plus keep right, differentiate left. Are you saying something? I can't hear you. Huh? That's it. What do you mean? Why? Keep left, differentiate right. Plus keep right, differentiate left. Okay? So, what trigo formula are you talking about? If that links up for you and you can remember, then so be it. For me, I don't draw that link. Yeah, okay? So, if you want to, of course, you can actually put the differentiation here in front and then this one on the right. That's fine, okay? But to usually what we will write will be this way lah, okay? So, therefore, right, after looking at this differentiation, our answer will be x plus 1 squared. The derivative of this one, we apply our chain rule. So let me use a different color. I will be getting 5 times 3x minus 7 to the power of 4 times 3. So chain rule applied. Then differentiation of x plus 1 squared will be bring down power to x plus 1 to the power of 1. Differentiation of x plus 1 is 1. I will get this. Then simplify our final answer. have this. Okay? Please look at it carefully and try to understand how this is done. Yes. Factorize, no need. You can leave your answer like this. You don't have to factorize it. Okay? But of course, it will also depend on the question. Okay? If the question expected into a certain form, right, then please follow the question's expectations. But by usual standards, this will be fine. Okay? Any questions here? Okay, let me just show you and explain to you with one example why is it that this rule doesn't work. Okay, so I'll just try 8, page 16, question A, to show it to you. Hang on, this is too difficult. Okay, sorry, I'll give a different simpler example. Let me. Okay, let's just do with this up. Alright? So what if, alright, this actually is true? Meaning to say, what am I going to get if I were to do this? Differentiate the left side and differentiate the right side. And then after that, I multiply it. What am I going to be getting? Okay, because they are a product, right? So, what I'll be getting with differentiation of 2x minus 7 is a 2. Differentiation of 3x squared plus 5, I'm going to get a 6x. So for differentiation, it seems I'm getting a 12x. Okay? But we know that from our very basic rules, our y equals to 2x minus 7 times 3x squared plus 5. If I were to expand it, I'm going to get 6x cubed plus 10x minus 21x squared minus 35. Agree? And if I were to use the expanded form to differentiate, I'm going to get this. Right? So clearly, we see that this and this are not equal. Okay? So therefore, this rule is not correct. Okay? And to prove it to you that my product rule over here is true, okay, it would be if I were to take, keeping the left side, differentiate the right, I will get 6x, plus keeping the right side, differentiating the left, I will get 2. Hang on, okay, expanding it, 42x plus 6x squared plus 10. Okay, did I do anything wrong? 6 plus 3, 18, right? 12x squared. Oh, sorry, simplify. 18x squared minus 42x plus 10. Okay, so if I were to apply my product rule, keep left, differentiate right, keep right, differentiate left, I will actually get this expanded and simplified to be this. So I'm showing to you over here that using my product rule gives me the correct answer to the differentiation. Okay? Whereas using your intuition to think that you can differentiate individually, that's not going to work. Alright? So I'm trying to emphasize on the product rule. Okay? Yes, Joseph. Yes. Any questions? Okay. In case you're wondering, instead of keep right, differentiate right, keep left, differentiate right, and keep right, differentiate left, can I do it the other way around? Okay. Meaning to say I keep the right first, differentiate the left, and then I keep the left, then differentiate the right. Definitely I can. Because this is a plus over here. A plus B and B plus A, they are the same. So that's why the order doesn't matter in this case. Okay, because it is a plus. Alright? So, but just keep it the same, okay? Don't keep trying to change your rule. At one point, this question you do keep left, differentiate right. Then after that, the other question you keep right, differentiate left. Just be consistent, so that your rule itself is well established. If you keep changing the way you see things, okay, it will be very difficult to manage. Alright? Any questions? Okay, so let's do an example. Try 8. Okay, so part A, we have y equals to 2x to the power of 4 minus 1 times 5x plus 6 to the power of 4. Okay, could I get someone to tell me what is dy over dx going to be? What will you start writing first? I think you know your product already, so I shall ask you. Okay, I should ask someone who doesn't know. Okay, so maybe Zhenxue, what do you think?
Write the first term.
Sorry?
Right.
First term, okay. Then
Bracket, differentiate the second term.
sorry? Differentiate this one.
4 times 5x plus
4 times 5x plus 6
6
to the power of 3.
and then differentiate 5x plus 6. So
Which you will get 5,
5
followed by
plus the second term.
plus the second term.
And then times 1.
Sorry?
Times 1.
Times 1.
And ax.
8x.
The power.
8x
Ax the power 3.
to the power of 3, okay. That's all? Okay. Are we agreeable to this? Pardon? No, not correct. What's not correct? We kept the left, right? Then differentiate the right side, correct? Okay, so this is the differentiate, right? And then after that, we kept the left, kept the right. And then to differentiate the 2x to the power of 4 minus 1, technically you don't need to put down the 1 here, okay? Because this one is just a term that's a power of 1. Directly you can differentiate the insides of it. You will get 8x cubed. So this will be not necessary. Okay. Then the next step, we try to simplify. We need to simplify it because we got a 5 and 4. We can multiply that to get 20. And then we have this. Okay? you look at part B, you want to differentiate this function in terms of t, which is square root t minus 1 times square root t plus 1. Okay? You want to expand it? A square minus b square. So the boys there actually suggest to expand and using our a square minus b square. How many of you would try to do that? A square minus b square. Okay, you can do that. In this case, you can also do product rule. Okay, personally, you will find that doing a square minus b square is a shorter step. Okay, as compared to applying product rule. Okay, let me show you both ways. If I use product rule, keep left, differentiate the right, I will get half t to the power negative half. Plus, keeping the right, I will get half t to the power negative half again. Okay, and then
For pi, you don't have to like factorize.
no need to factorize. You can leave it like this. Yeah. You don't have to factorize. Factorization does not mean simplification. Okay? So this is also considered simplified form. Okay?
So do you have a conclusion?
So yes, in this case, right, okay, you can merge it together because they are both having the same denominator. So sorry, I'll just continue here. So upon combining the fractions, okay, and simplifying the numerator, notice that the derivative is equals to 1. On the other hand, if you were to just expand and simplify it using your identity of a square minus b square, your derivative is just 1. No need to actually go through the steps. Okay.
They ask us to show it without
Yeah, but usually the exam they will not specify what rule you need to do. Okay, because it is expected of you to know what rule to apply. Yeah. So exam will not give you the hint that way. Knowing how exams are set, I will not waste giving marks like that. Okay, so either ways are not wrong, so up to your preference, and of course up to what you first think of. Okay, we have 10 minutes. I just want you to spend the remaining time, okay, to do exercise 12.3. Okay, 1A, 1D, 2A, 2E. Okay, to practice your product rule. Today's lesson.
Also,